published this paper a year and a half ago called A Path Towards Autonomous Machine Intelligence. I replaced autonomous now by advanced because autonomous sounds scary. And it's on open review, it's not on archive, because on open review you can comment. The basic idea here is some sort of what people used to call in the old days a cognitive architecture. So basically a modular system composed of multiple modules. So each module, think of each module as some big neural net. And each arrow carries signals forwards, but also carry gradients backwards, okay? So think of this as kind of the big neural net macro architecture, and you can backpropagate gradient to the entire thing. So the red stuff at the bottom is a set of cost functions, and those only have arrows coming into them. They compute a cost, and then you can compute gradients of this cost with respect to all the parameters in the system by backpropagating along the other arrows. Okay, so what's happening? The system observes the world. The world goes into the perception that gives an idea of the current state of the world, perhaps combined with a memory. That goes into a world model whose role is to predict what's going to happen if you take a particular sequence of actions. The actor imagines a sequence of action and then uses the world model to predict what's going to happen. And then that goes into the cost module, which evaluates whether the outcome of this sequence of actions predicted by the world model is good or bad. Okay? And you can propagate gradients or whatever so that the actor can optimize its sequence of actions so as to satisfy the goal. So if I draw this in a way that's slightly more understandable, it looks like this. Okay? Observe the world, go to the perception system. Perception system figures out some representation of the state of the world, combined with memory, which perhaps has some previous information acquired about the state of the world. Goes into the world model. The world model also takes the action sequence, an imagined action sequence, and predicts the outcome of taking this action sequence given the initial state of the world. And that goes into different terms of the cost function, a task objective that measures to what extent the outcome satisfies the goal that the system was given, the objective. And then perhaps a bunch of other costs that are guardrails. So things that guarantee that whatever action the system takes are not going to kill anyone or destroy the machine or whatever, right? Guardrail objectives. And the way the system operates is that through some optimization process, it tries to figure out what action sequence will optimize those guardrails given that the world model is predicting the outcome. Okay, so that's an optimization process. So this is fundamentally different from what we usually do with neural nets, which is we run through a bunch of layers and we outcome an output, right? There's a finite number of steps to produce the output, a given number of steps. Here, the output is produced by optimization. This is not a new concept at all. This is the way inference was, works in probabilistic models, in latent variable models, in graphical models, probabilistic graphical models, things of that type. That's the way it works. You know certain variables, and then you infer the value of the variables you don't know, or distribution over those variables. It's the same thing here. You observe the state of the world, and then by optimization, you infer a sequence of actions that minimize a set of objectives or maximize some negative some likelihood or log likelihood or whatever. So that's objective-driven AI.